Hi students, welcome to Alphos e-learning program mathematics class. In previous session students, we have been discussing about properties of tangents, right? Properties of tangents. In last class also we have discussed a concept basing on GP, right? In previous session. Now here also another concept is in GP. Again here also this is GP but under different conditions. Let's have a glance students. If the distance of 2 points P comma Q on a parabola. So on a parabola given, again as usual we are taking the standard form y square equal to 4ax. Now this is P and Q, these are two points on the parabola. From its focus S are SP and SQ. So these are the distances, and you know, as long as P and Q are on the parabola, we say these are focal distances. So SP is a plus at1 square, SQ is a plus at2 square. Formula mod x1 plus a for focal distance when x1 y1 is on the parabola, right? And next one, the distance of point of intersection of tangents drawn at P and Q. Okay, so a tangent is drawn at P and a tangent is drawn at Q here. Now the point of intersection of tangents, this is now T. Okay, now what they are telling, if this is ST, that means S to T, the distance from focus to the point of intersection of tangents drawn at the points P and Q, if it is ST, then the value they are asking here, then SP comma ST comma SQ are in GP. That means this SP, ST, SQ, okay, order. Now in previous session students, we have discussed again the same concept of GP, but in what way actually we have done. Suppose a parabola is taken and a tangent is drawn at a point P, okay, at any point P. And now this one is exactly our which one here, tangent at vertex, that is A, okay, and this is the point of intersection of tangent at vertex and here this one, that is Q. Then if you take here focus S, then SA, SQ, SP, these are in which one, again geometric progression. So there we have used actually the tangent at vertex, tangent drawn exactly at the vertex and tangent drawn at any point P if they are intersecting at Q, then SA, SQ, SP, those are in GP, that we have derived in previous session. Now you are using here no tangent at vertex, nothing, just we are taking tangents are drawn at 2 points, okay. These are not focal coordinates or nothing, no other instructions here, just tangents are drawn at 2 points P and Q and they are intersecting at T, right. Now SP, ST and SQ, these are always in geometric progression. Then what about here, how you can just 2-3 lines only the proof, that is nothing but here SP value. What is SP value? It is x1 plus a, so it is a plus at1 square, our formula. And SQ, again the focal distance formula students, it is a plus at2 square. So these two you know clearly. And you know about the point of intersection of tangents drawn at T1 and at T2, that is at1 T2 a into this value. And what about here distance formula, just it is nothing but distance formula, that is ST value. If I use the distance formula here, it is nothing but a minus, I am taking ST square, so it is a minus a T1 T2 whole square, and next value how much it is, plus a T1 T2 this value minus 0 whole square, so a into T1 plus T2 whole square. So this is the value we got here from distance formula S and T. And now this is nothing but if I take a square common from the entire thing, 1 minus T1 T2 whole square, if you expand 1 plus T1 square T2 square minus 2 T1 T2, and this one is here plus T1 square plus T2 square plus 2 T1 T2, okay. Now let's cancel these two values. Now it is of the form students 1 plus A plus B plus AB. So whenever you observe 1 plus A plus B plus AB, it's nothing but 1 plus A into 1 plus B, okay. No need of taking common in that way, directly you can use. So it is of that form 1 plus A plus B plus AB. Therefore you can write this as A square into 1 plus T1 square into 1 plus T2 square. clearly what is that value here? SP into SQ. Okay, if you take a common here, it is a square. 1 plus T1 square into 1 plus T2 square. So simply this is nothing but here SP into SQ. Therefore what we can conclude is nothing but here ST square equal to SP into SQ. Hence we can see here these three values are always in geometric progression. So lengths of here segments given. This is not focal chord, nowhere they have mentioned, students, observe clearly. It may or may not, but not necessarily be a focal chord. So SP1 segment, SQ another segment, and tangents are drawn at P and Q and they are intersecting at P. No restriction, the tangents are drawn at the ends of focal chord, nothing, no restriction, just at the points on parabola, and then we got this kind of condition. Okay, therefore SP, ST, SQ, these are in which progression? Geometric progression, right? And now let us observe, students, the other one. What is the other one? The other is nothing but AB and AC are tangents. Okay, AB and AC are tangents drawn to a parabola. To a parabola, two tangents are drawn. That means just like this, two tangents are drawn. And next one is P1, P2, P3 be lengths of perpendiculars drawn from 3 points, okay, A, B, C respectively on any tangent. Okay, students, so observe here clearly the data. What is the data given in the problem? The data given as here AB and AC are two tangents. Okay, AB and AC given are here two tangents to a parabola. Again we are taking here the standard form. What is the standard form, students? Here it is y square equal to 4ax. So this is our standard form we are taking. And now what is the data here? AB, AC are tangents to a parabola. So this one is here one tangent I am taking, and next this is another tangent you are taking, and they are telling here this is A, B, and this one is here C. Okay, AB and AC are two tangents. And again you observe, students, clearly they did not mention any restriction. So that means here B and C are ends of focal chord like that, no restriction given. Therefore let us take this again, AT1 square comma 2AT1, and this C as AT2 square comma 2AT2. Okay, then what about here point of intersection? This is nothing but again A T1 T2 comma A into T1 plus T2. Okay, students, so in this way we can write here coordinates of A. Understand? And next one, what is the other value given? P1, P2, P3 be lengths of perpendiculars. Okay, P1, P2, P3 be lengths of perpendiculars drawn from where you are drawing A, B, C respectively. Okay, so now you have to take P1, P2, P3 lengths of perpendiculars drawn from A, B, C respectively on any tangent to the curve. Understand, students, here on any tangent they said. Okay, on any tangent to the curve they are telling. So whenever you come across these kind of problems in exam, if you take the any tangent drawn at T, suppose, again the procedure will be lengthy one. Therefore for our comfort, just you can take here on any tangent, means just for our comfort level we are taking here tangent at vertex. Okay, so just to make the proof short I am using here tangent at the vertex. So if this is the origin, our tangent at vertex to the standard form is nothing but here y axis, right? This is y axis, and you can use here, instead of, if you don't want this one, you can use at any point T, you can use that is yt equal to x plus at square. Okay, this also you can use and find here P1, the perpendicular distance from, it is which one? A. Okay, perpendicular distance from A onto this line. Then we can make use of formula for perpendicular distance. And again for P2 you can apply, again for P3, okay, by taking like this. But if I consider in this way, maybe it is lengthy as we are doing objective approach. So I am using just here tangent at vertex, right? So what is our tangent at vertex to this parabola? It is y axis whose equation is x equal to 0. And what about this point here? It is 0 comma 0. Okay, now what is foot of perpendicular from the point A onto this, okay? You know all of you clearly what is that value from here to here. Ordinate remains the same, but which one is varying here? This one if I take here, this is nothing but only AT1, T2. Therefore, let us write here P1. This is nothing but what here? AT1, T2. Okay, so P1 is this value and P2 it is drawn from B. Okay, P2 it is drawn from B. So from here to here, this is our P1 and this one is our P2. Don't understand here, I have taken it origin. Okay, now it is here from P2. Suppose if you take this is the length is P2 drawn from B onto tangent at vertex, then ordinate remains the same. Therefore this value, how much it is? It is coming as again 81 square. Okay, from here to here you are taking, it is nothing but 81 square. So P2 is 81 square, and next in the same way P3 is what here? It is a T2 square. Okay students, then what about the progression? The order is here, progression order. Which one you are taking here? P2, P3. The product if you take P2, P3, then this is nothing but what here? P1 square. Okay, so P2, P3 is nothing but here P1 square, that is a square T1 square T2 square. Therefore here they may give the order in this way also, that is this is here P2 and this one is P1, P3, or they may give here in general. What about those three values? Those three lengths, they are nothing but in geometric progression. Okay students, so therefore here any question given as geometric progression or arithmetic progression, whatever, every problem you may or may not taken as a property. Okay, whatever problem it is given, no need of this has to be by hearted or this has to be by hearted, not necessarily to do all these things, just it is sufficient if you know the concept very well. Okay, what concepts we have applied here? We have applied here a point on a parabola, point of intersection of tangents, and in this problem actually we have applied actually focal distance formula, etc. Like that, whatever we know those only we are using, but everyone no need of remembering as formula. Whichever parabola they are asking here, you just take the proof by using the standard parabola y square equal to 4ax. Okay, now observe students, this is one of the other, seems to be a property, but even no need of using property by hearting like that, just you can do this kind of problem. Observe the line joining orthocenter and centroid of a triangle. How is the triangle here? The triangle is forming by a focal chord and tangents drawn exactly at its extremities. Okay, then what about the line joining orthocenter and centroid? How it is that one? That means parallel to, they give options as axis of a parabola, directrix of parabola, or something they may give here, or sometimes they may give here numerical values and they will ask about that kind of equations also. Now again, to make use of this one, just let us take the parabola standard form y square equal to 4ax. So if I draw the curve, y square is 4ax here, this is the parabola, y square is 4ax. Now tangents are drawn, they said here at the extremities of focal chord. Okay, so if I take here, this is the tangent drawn to the extremities. So one is this tangent actually and this one is the other tangent, and all of you know whenever tangents are drawn at extremities of focal chord, they intersect on directrix, moreover at right angle. Okay, they intersect on directrix at right angle. Therefore clearly this line is nothing but what here? Directrix. And to the standard parabola students, what about here? This value, that is it is y square is 4ax. Now I am taking directly one of the focal chords here, not taking here lattice rectum or anything. I am just taking a general focal chord. Okay, now this is the focus actually, it is s of a comma 0, right? So this is s of a comma 0, and now here what about this point of intersection? So this point of intersection means all of you know clearly, it is tangent drawn at 81 square comma 281 suppose you take, and this one is at 82 square comma 282 suppose you consider. Then what is the property if it is a focal chord? The property is nothing but what? T1 T2 is equal to how much? -1. So by keeping that value in mind here, what about here? Point of intersection of the two tangents, it is a T1 T2, but what is T1 T2 here? It is minus 1, therefore minus a, comma, what is the other value? It is a into T1 plus T2. Okay students, so this minus a you got because of the reason the chord is nothing but a focal chord. Therefore in the formula a T1 T2 comma a into T1 plus T2, which is point of intersection of tangents drawn at T1 and T2, we have taken this value as how much here? Minus a into minus 1 minus a, and this value as it is. Therefore this is our point of intersection of tangents, which is exactly on directrix. Okay, then clearly you know this triangle is nothing but here, if you name this one as P here, Q and R, then clearly you know all of you that PQR is nothing but a right angle triangle. And for any right angle triangle, again we know here orthocenter is nothing but the vertex at the right angle. So here what is the vertex at the right angle? Exactly this point. So students, what is the orthocenter of our problem now? The orthocenter is clearly, it is P, which is at the right angle position, and the coordinates are minus a comma a into T1 plus T2. Okay, so we have taken here the advantage of focal chord. And next one is here, they are telling about the centroid of triangle. Okay, so the centroid of triangle, you know PQR centroid. They are asking about here the triangle, that is here PQR triangle. For PQR triangle, which is formed by focal chord and tangents. Okay, so this is the focal chord and these are the two tangents to this. Now we want to find here centroid. So what about here centroid students? So this one centroid G equal to the same triangle, you know the formula, it is minus a, okay, plus 81 square plus 82 square divided by 3, right, comma, the ordinate value, it is a T1 plus T2, 2a T1, and this is here 2a T2, okay, divided by how much? 3. Then what is that value here? This is a into T1 plus T2, and next the other value is 2a into T1 plus T2. Okay, so plus 2a into T1 plus T2 divided by how much? It is 3, right? And now what about here these coordinates? So centroid is nothing but here the first one we are not going to simplify, a into, suppose if I write T1 square plus T2 square minus 1 divided by 3 comma here 2 times and 1 time, therefore it is 3 times. Hence it is a into what? This value T1 plus T2. Now observe clearly students here, what are ordinates of this orthocenter and centroid? The ordinates are here nothing but here it is a into T1 plus T2 and here also it is a into T1 plus T2. So to these 2 points here you observe clearly ordinates are same. So to any line joining points, if ordinates are same, what is our conclusion? That line is actually parallel to x-axis. Okay, therefore here we can say the line GP is parallel to x-axis. So here what is x-axis to this parabola? This is nothing but here what is that one? Axis, implies GP is here parallel to axis of parabola. Okay, so simply you can do in this way students, everything not necessary. Okay, this is maybe one of the other properties I have to remember, in that way not necessary, just whatever parabola is given in the data, but just you take the help of standard form and using the standard form you derive condition and then generalize. That means in this problem if at all given one of the options as x-axis, so immediately you should not conclude the answer is x-axis. As you have taken this parabola, therefore you got the answer as x-axis. But in general, what is that line? Actually, it is nothing but axis of parabola. Okay, so like that here, while giving conclusion, it is very important to you what you are giving exactly, generalizing the concept. Okay, generalizing the concept. Here you are generalizing as axis of parabola due to the reason this is ordinates are here same. Okay, so here we write as ordinates are same. This is the reason we can write in this way. Okay, these are same. Therefore, we conclude here the line GP is parallel to x-axis, and hence in general the line joining orthocenter centroid is nothing but parallel to what here? Axis of that parabola. Okay. Now students, we have observed so many properties of tangents till now. Okay, so whatever properties we have started, you have to go through them thoroughly. Very important few properties. Now this is a very good problem, interesting problem, which has covered many properties to solve this problem. So once you solve this problem, students, you can understand what is the importance of tangent properties. Okay, but nothing to afraid. Whenever any tangent property is there, just roughly take the parabola. Y square is 4ax. If you prove one or two problems, if you solve easily, you can remember. But just write all the properties at one stretch and just recollect and try to remember all those, right? Now let us have a glance on this problem. Very interesting problem this one is. This one is a parabola is given. The name of the parabola they are telling as P, and it is touching y is 0. Y is 0 means nothing but x-axis at 1, 0, and x is 0, that is nothing but y-axis at 0, 2. Okay, so x-axis at 1, 0 and y-axis at 0, 2. And next one is here they are asking find values of focus, directrix, everything. Okay, then here we know very clear, students, that you may think here the doubt you can get immediately. The parabola just now I have drawn in that way, but once these are the 2 points, you may think here why not the parabola exactly like this also. Okay, so if I draw parabola in this way, then it cannot touch, isn't it? It cannot touch x-axis or y-axis. That's why only it is necessarily you have to draw in this way, so as to the parabola has to touch here coordinate axis. Okay, so as the parabola has to touch here coordinate axis, therefore the parabola you have to draw in this way, but we can't draw like this. Okay, now the next one is here they are asking about, this is the only information given, that parabola is touching here 2 lines at 2 points. Points of contact given, coordinate axis given. Now they are asking about all details regarding the parabola, that is focus, directrix, tangent at vertex, equation of parabola. They may ask lattice rectum, anything. Okay, so you can find easily once you know about here few values. Now how to find here actually the focus? First of all, our interest is focus, directrix. Okay, once you know focus, directrix, students, then easily you can get all other. Or else if you know about here tangent at vertex and axis of parabola along with lattice rectum, then also you can find remaining values. Now how to find here different values? To that, observe here clearly, this is a tangent to the parabola and this one also tangent to the parabola. You know clearly these 2 lines they intersect at origin. Therefore the 2 tangents drawn at the point A and B are intersecting at right angle. Okay, these 2 tangents they are exactly at right angle, and you know the concept, whenever these are intersecting at right angle, definitely the origin is must be on which one here? Directrix. Okay, so the origin has to be on directrix here, because 2 tangents on directrix always intersect at right angle. Okay, and next one is, what about at that stage tangents drawn these 2 ends? These 2 ends, then definitely they are exactly what actually ends of a focal chord. Okay, so first property now we are utilizing 100%. So how you are using? 2 tangents are drawn, they are intersecting at right angle, and therefore this is nothing but the point of intersection must be on directrix. And next one is the tangents drawn whenever they are at right angle on the directrix, definitely they are drawn from the ends of a focal chord. Therefore if I join this line AB, okay, if I join this line AB, then definitely somewhere is our focus. So what about here? Coordinates of focus, first interest. Understood all of you? Now we want to find here focus coordinates, right? Now to find here focus coordinates, again you have to make use of another property. What is the other property? Observe students here. So first property we have observed, Tangents drawn at 1, 0 are perpendicular, 0, 0 lies on directrix. Moreover, what is the other one we have applied here? It is nothing but AB is nothing but what here? Focal chord, because of this reason. Okay, because of what reason? As they are meeting on directrix along with right angle, therefore that is always must be from the ends of always focal chord. Okay, so here AB we decided focal chord, it is passing through focus. And once it is passing through focus, here what is the slope of this line AB? Okay, so what is slope of line AB? 2 minus 0 divided by minus 1. So slope of line AB is nothing but, students, it is how much? Minus 2. Okay, then equation of line AB I want to find. So what is equation of line AB? Okay, equation of line AB, if at all you want to find, then you can decide here, that is nothing but y minus 0 is equal to minus 2 into it is x minus 1. Therefore y plus 2x, or it is 2x plus y, and minus 2 equal to how much? 0. Okay, so this is our equation of line AB. Okay, 2x we have taken this side, plus y, and plus 2 this side, it is minus 2 is 0. Now you may get doubt here, exactly it is focal chord or not. To that also you can think in this way, that is we have observed the focal, the length of the portion, okay, the length of the portion between tangent and the directrix. The portion between tangent and the directrix is always subtends right angle at the focus. So this is again one of the properties we have observed. If you have taken a tangent like this, understood? This is any tangent, okay, any tangent, and this is our suppose focus here, and next one this is suppose directrix. Okay, directrix. Now this value is P and it is Q. All of you know clearly we have done, this is directrix, actually the length of the portion which is between the point of contact and point on directrix, always this portion subtends right angle at the focus. Okay, so basing on this, students, here you can observe clearly angle OSB is 90 degrees. Okay, this is the tangent drawn to the parabola. Okay, this is any tangent, and next one is here, this is our directrix. Therefore you can observe here this angle is exactly how much here? 90 degrees. Again in the same way, if you observe this angle also here 90 degrees. That means here these 3 points are clearly collinear. So in that way also you can decide here OSB 90 degrees, OSA is 90 degrees. Therefore you can say here these 3 are collinear. You can make use of focal coordinates or else in this way also. So we got decided here the focus is exactly on the line joining AB, right? And next one is here this value here 90 90 implies, students, what about here the relation between OS and this AB? Okay, OS and AB, because of this relation you observe here this is nothing but what here? 90 degrees. Here also 90 implies the line joining OS is exactly perpendicular to what here? The line AB. Okay, if you join this one, this is 90 degrees because of our property this one, and therefore here clearly you can say this one is 90 degrees implies line joining OS is perpendicular to AB. Okay, now our interest is actually what is OS line equation. You know already AB line equation. If you find OS line equation and if you solve them, you can find focus coordinates. Once you know focus value, rest all you can get immediately. Therefore here, students, we decided now OS is exactly perpendicular to which one? It is AB because of this reason. Okay, so basing on this reason, students, now I decided OS perpendicular to AB, and hence here equation of line AB we are taking. What is equation of line AB? This slope is here minus 2. Therefore, slope of OS is how much here? Slope of OS is nothing but 1 by 2, right? This is slope of OS, students, it is 1 by 2, and therefore now we can write equation is y minus origin you are using y minus 0 is, this is 1 by 2 into x minus 0. So this is nothing but how much? Y equal to x by 2. Now if I solve these two equations, okay, these two equations, the point of intersection of lines AB comma the other is OS gives which value here? The focus coordinates. Okay, this is giving focus coordinates. Now let us substitute y is x by 2 here, students. So 2x plus x divided by 2 equal to 2. That implies 5x divided by 2 is what here? 2. Implies x equal to what here? 4 by 5. Once x is 4 by 5, y is x by 2. Okay, then what about y value here? X by 2 means 2 by 5. Therefore, these coordinates are nothing but 4 by 5 comma 2 by 5, right? And this one here you got, students, about the coordinates of focus. Once you know about focus coordinates, the next interesting point is here, directrix slope we require. To obtain directrix slope, you know all of you clearly, tangent at vertex and directrix are always parallel. Okay, so these two are always parallel. Therefore, again I am going to use another concept of this tangent at vertex, that is nothing but, what is the formula here? Foot of perpendicular drawn from focus on any tangent lies on tangent at vertex. So this property also, students, we have done. In what way we have done this property? The locus of feet of perpendiculars drawn from focus on any tangent. Okay, on any tangent, always they lie on which one here? Tangent at vertex. So the locus is nothing but what there? Tangent at vertex. Therefore, students, you observe here, this is the focus and this one is the tangent at vertex and this is the tangent drawn if you observe this side. Okay, if you observe this x-axis is the tangent here and I am taking exactly perpendicular onto x-axis. Okay, so exactly perpendicular onto x-axis I am taking. Now this point is what here? 4 by 5 comma 0. Okay, na? So this is 4 by 5 comma 0. And in the same way, students, you take here foot of perpendicular from the same focus onto which one again here? This one. Okay, onto this one. This is the tangent. So you are using one time x-axis as the tangent and another time you are using here y-axis as the tangent. And therefore, if I take here perpendicular onto this one, this is again next point, tangent at vertex. Therefore, what about these coordinates here? It is 0 comma 2 by 5. Okay, 0, 2 by 5. And hence here the slope of tangent at vertex easily you can deduce. So this property also we have used. Now I think, students, all of you are observing what properties you have been using. Almost whatever till now we have done, many of them we are using here. Therefore, here this is the property, the foot of perpendicular drawn from focus on any tangent. So one time we have used here x-axis tangent and next time I have used here y-axis tangent. Okay, then this is the point on tangent at vertex and this is also the point on tangent at vertex. And the line joining, if you find here slope of these two line joining points, then you can obtain directly, that is slope of what here? Directrix. Okay, so now let us find here slope of directrix. That means first let me take here slope of tangent at vertex. So what is slope of tangent at vertex? This one is basing on this property. Okay, so slope of tangent at vertex, it is nothing but the value is how much, students, here? 2 by 5 minus 0 and divided by denominator minus 4 by 5. Hence this is nothing but minus 1 by 2. Therefore, slope of directrix is how much here? It is minus 1 by 2. As the slope of directrix is minus 1 by 2 and it is passing through origin, therefore equation of directrix, okay, equation of directrix is nothing but y equal to mx. Y is here, m means minus 1 by 2 into x. So you got now directrix equation. Okay, so directrix equation, students, you got, that is y is minus x by 2, focus you got. Then if you use the formula SP equal to PM, okay, SP equal to PM, you can obtain clearly equation of parabola, alright. And after that, if at all they asked, so focus you got, directrix you got, tangent at vertex also we got, understood. And if you write equation of line, intercept form x by 4 by 5 plus y by 2 by 5 is 1, okay. So in that way you got all values. And if at all they ask about even lattice rectum, okay, what about lattice rectum here? Find here perpendicular distance from focus onto tangent at vertex, right? And that one is A, okay, distance from focus to tangent at vertex is A. And then here the 4 times that A is nothing but length of lattice rectum. So if at all lattice rectum they asked here, what is the formula, students? 4 times it is perpendicular distance from where here? From focus onto which one here? Tangent at vertex. Or if we have all you want here, you can take 2 times from focus onto directrix, okay, 2 times from directrix you take, or 4 times from tangent at vertex. Anyways you can use, students. So in this way the formula, that is the properties, you can use effectively. So in your hand, if you are having these bunch of properties, then easily we can solve these kind of problems, okay. So just nothing to worry about all the properties. Please write them on one paper clearly. Whatever we have started with the tangent properties, write all of them on one paper and practice those just by taking the standard parabola y square equal to 4ax. Anytime if at all you forget also, immediately just take the standard form, derive. It won't take whatever properties till now we have derived, they are not taking that much time, just 2-3 steps only you are getting, okay. So in that way, students, better remember but the basic properties which we have discussed, first 5 or 6 properties, okay.